So for emission of laser from helium neon laser, we need drawing. This is what helium neon laser apparatus looks like. There's a mirror. There is a mirror too. Now one of the mirror is 100% reflecting and another is 99% reflecting. This should be 99% reflecting because we will need this to emit the laser out from this box, from this whole apparatus. Now this inside here is these two gases, helium and neon. I have drawn the atomic structure of helium and neon here. Now in helium there are two electrons. This is not an electron, that was a mistake. But there are two electrons. Now, and in neon there are 10 electrons, 2 on the first orbit, and in the second orbit there are 8. Now these are where the energy is supplied to the gases. There are the gases. From these wires energy is supplied, potential energy is supplied. Now when the potential energy is supplied to the gases, the helium gas gets excited to 2s. This is the 2s level. This is the orbit where this, suppose this electron gets to there. Now this, when this electron goes there, there is a vacancy on this electron. To fill this vacancy, this upper electron must go down. But in this case, this state is the metastable state of this, or this is the state in which helium is metastable. What metastable means is, it means that the electrons take longer time to get from there to there compared to the normal excited state. So in this state, this electron stays here longer. Now when this electron is on this orbit, this helium atom moves in random direction. Gases do always move in random direction. Both helium and neon are moving in random direction, and we put helium and neon in such a ratio that it is 5 part helium and 1 part is neon. So basically, if you put 5 liter of helium there, you need 1 liter of neon. And also to remember, this chamber is on the pressure of 1 torr. It basically means 1 mm of Hg. Now when there are more helium atoms than neon atoms, so the majority of the atoms present in this chamber get excited because the majority of atoms are helium. Now when the helium gets excited, it's moving in random direction. When it's moving in random direction, it has certain kinetic energy. So when energy is supplied to the helium, or rather the helium gets the energy and jumps to the excited state, it moves randomly, and when it moves randomly, it collides with the neon atoms. Now when it collides with neon atom, it excites the neon atom to 5s. Let us consider this to be the 5s orbital, orbit, whatever you want to call it. Now one of the electrons jump to this orbit. Now this is vacant. Now this neon atom is also excited. Now the energy the neon atom has is greater than the energy helium atom had when it was excited by this potential. Why? Because gases are moving in random direction, and when helium moved in random direction, it had some kinetic energy as well. So the kinetic energy of this gas plus the energy it got from this potential, let's call it potential energy, these both are transferred to neon atom. So neon atom has a little bit more energy than this. Now numerically when helium is excited to 2s state, it has energy of about 20.61 electron volt. That's the energy of the helium atom when it is excited. Now it gains some energy on kinetic energy, which is around 0.05 electron volt, and when these two together collide with neon, it excites neon atom electron to excited state, giving it energy of 66 electron volt. Now when this 20.66 electron volt electron or atom is excited, it goes under decay, not rather decay, it goes on disintegration too. Now remember, this is not the next orbital after the second orbit. This is 5s, not the orbit after the L. So now this there are few more orbits in between the 5s and the second orbit. Now in order to get here, this electron first goes disintegration into the 3p orbit, in which it loses some energy in form of radiation, of course, and the radiation that is emitted from this process, it is the radiation we need for the emission of laser. The frequency of this laser or radiation is around 632 nanometer. This is what the laser is. Okay, now the energy lost when it jumps from this 5s to 3p, it is around not 18.3 eV. This is the energy, and this is the energy of the atom when the electron is in 3p orbital. Now the energy lost from 5s to 3p would be this is the energy lost by the, or in other words, this is the energy of the photon or the radiation of the single atom of which went to disintegration. Now this is still not stable, because this electron has to go to the vacant place where its own original place was. This place is 2s, because the electronic configuration of neon, you can just Google it. Now this will go in disintegration even more to 3s orbital. Now when this goes disintegration into this, it gives This gives a spontaneous emission of radiation. Basically, this is a normal radiation. This is not laser radiation. This we don't need this radiation. And further, it goes disintegration to 2s state where it is stable. It does not have any energy on this state. And the radiation emitted in this when it goes from 3s to 2s is non-radioactive. So basically, it does not emit any radiation when going from 3s to 2s.